Guys, so welcome to Blue Tech Empire Python tutorials. In this video we are going to be looking at introduction to Python programming. So I'm going to be covering a lot of things in this video tutorials. Some of the things I'm going to be covering here include Python programming modes, Python identifiers, reserved words, lines and indentation, multi-line statements, quotation in Python, comments in Python, blank lines, waiting for user input, multiple statements on a single line, and multiple statement group as suites. So let's get into the video. So I'm going to be using the content on the Telegram channel. If you are not if you like to follow up on this on the content on the Telegram channel, you can join the Telegram channel. The link was on the initial screen, or I'll also drop the link to the Telegram channel on the description of this video. So let's get started. We are going to start from here. So we all know Python is a programming language that's used for several stuff like data science, data analysis, data visualization, artificial intelligence, deep learning, everything. Web design, graphic user interface design, even graphic design is used in back-end servers. Mostly it's used in back-end servers most of the times, and it's also used for cyber security. It's even used for embedded system design. You know about the Python embedded system design module used by students. I've just forgotten the name. Similar to Arduino, the Raspberry Pi module. You use Python to program it, and it's an embedded system design which you can use to design small projects for those doing electrical engineering or those doing some kind of electrical physics or something. Most of them use Raspberry Pi. So Python has a lot of uses. It's very good to know. You can use it for web design. If you use a Django framework, it's built on Python. So Python has a lot of uses. So learning Python is very essential these days because technology is really at the trend. So learning Python already puts you ahead because you can apply Python in any field: agriculture, medicine, nursing, whatever field you're into. There's some form of programming to automate tasks, to do things quickly. You can't be doing things with your hands. Everybody now needs the computer is being put into use very seriously now, especially in these days of data science and cloud computing. So having a knowledge on programming, especially simpler programming like language like Python, it's very, very important. So Python supports several data types: number, string, array, list, tuple, dictionary, set. There are many others which are not really common that is supported by Python. It's in the Python library. If you visit the Python manual, you see a lot of other data types like quicks and stacks and all these complicated data types. But we are going to be looking at the simple data types provided by Python, which you are going to be using in your everyday life. So let's get started with the interactive mode of programming. So to pop up the interactive mode, what we do is normally we have to just go to your command line by typing cmd. You can run as administrator if you're going to do any administrative tasks, but we are just doing normal Python scripts. So we are going to open the command prompt right away. Now you type Python. Now if you have not installed Python on your computer, or if you want to learn how to install Python at fresh, that's from crash, you can watch the video I did on that. So you can watch our video on installing Python. I think it's at the top right, or you can search for it in among the videos of this channel. So I'm going to put this here. All right, so to start the interactive prompt, what you type is Python or Python 3. Just type your Python command. It's all in the video I'm telling you about. So Once you type it, you see it gives us an introduction about Python. It tells us the Python version. I think you can even type just I don't know if let's and to exit this interactive prompt, you type exit. Exit is a Python function. You can use it within a Python script. Why? Because this triple caret right indicator you see here indicates you're within a Python interactive prompt. Anything or whatever command, whatever you type in here should be something which is accepted by Python. Whatever expression you type here should be a Python expression once you're inside this interactive shell or once you're within this interactive prompt. So for example, I want to exit, so I press enter. I'm back to the normal command line. So sometimes you can type Python version like this, but I don't know if it's going to work. All right, to check your Python version, it also indicated here. But to check your Python version, you can type Python and double dash or double hyphen and version. It's going to show you the version of Python. So let's get back into Python. I'm using Python version 3 as Python version 3.8. So if you want to download Python, probably you should download also version 3.8 point something. There's also version 3.9, but I think version 3.8 is stable. So I would advise you to download Python version 3.8. So we go to Python. Now, we are within the interactive prompt. The use of the interactive prompt is to try out stuff. So you can use the interactive prompt to write very complicated programs too. But remember, everything you type on the interactive prompt is lost after you close the shell. That's the difference between the interactive prompt and the scripting mode and the interactive mode of programming. Now, within the scripting mode, you write the whole script and you call the interpreter to interpret it. But while in the interactive prompt, every line you type after pressing enter, the interpreter interprets it. And if there's an error, it's going to tell you. For example, if we say list 1 equals to 1, 2, 3, I mistakenly ended it with a curly brace with brackets instead of square brackets, and see what happens. That's an error, while the interpreter gives me an error. Now, so I'm just trying to show to you that every line you type on the while in the interactive prompt, after pressing enter, it's interpreted by the interpreter. If there's an error, it's going to show you. Now, within the interactive prompt, you can write any piece of code. You can test pieces of code. For example, you can say you can use it as a simple calculator. 2 times 3, 4 times 3. You can use it as a calculator. You can create variables like num1 equals to 30, num2 is equals to 50, product is equals to num1 times num2, print product. Alright, so you can use it to write simple programs. You can also test you can also call methods. For example, if we have a list called list1, which is equals to 10 1 2 3 4 9 10 40 20 and 11. Now with this you can find call methods on list1 such as list1 dot sum all items in list1. Alright, no, sum, you can say sum list1. You can find the smallest value in list1 by using min. We are going to learn all this. I'm just showing you what you can do with the interactive prompts. You can find the largest value in list1 by using max. You can even find the length, that's the number of items in list 1 by using len. And you can even sort list 1 by calling list 1 dot sort. Now if you print it out, look at what you have. Print list 1. All right, you see it has been sorted out 1, 2, 3, 4, 5, 9, different from when we created it. So I just want you to see that. Right, so right, just give me a moment here. All right, okay, so you can do a lot of things with the interactive prompt. For example, I would like to add an item. I want to add 99 to the back of the list. I will just say list 1 dot append. We are going to learn about lists. I'm just showing you guys. Now if I okay, list 1 rather than list, it's list 1. All right, now if you print list 1, all right, so you can do a lot of things with the interactive modes. You can even, for example, if I want to know the current working directory, I can even import a module within the interactive mode. Import os.get current working directory, tells me where I am. So you can do all this, you can do a lot of, we are going to be, every time I do a program on the scripting mode, I'm just going to show you a hint on what can be done on the interactive mode. So this is called the interactive mode of programming, but there is something you need to note about the interactive mode of programming, and I'm going to show you right now. For example, if you write 3 times 5, the interactive mode is going to print out the result before it shows it it requests for your next statement, or before it prompts for you to get it enter another statement. So interactive prompt. So but if you assign this to a variable, let's say product or prod equals to 3 times 5, at this point, you see nothing was printed out. Why? Because the result of 3 times 5 was assigned to an identifier or variable name called prod. So the interactive prompt did not print it out. Thus, each time you have a statement has an output, and that output is not assigned to a variable. We are going to learn about variables soon. It is printed out by the interactive prompt. But if you don't want it to be printed out, you have to assign it to a variable. So if I print product now, you see the results. So I'm going to do another example. If I create a list, for example, if I just create a list on the fly and I sort it, it has no output because the sort method sorts the list in place. This may be a bit complex for you, but in case I, for example, say 3 raised to the power 5, it's 15. But if I say var1 equals to 3 raised to the power 5, it saves the result in a variable called var1, so it's not printed out. So but I can print var1 if I want, or I can even add another number to var1 plus 1. You see, var1 plus 1 now is 3 raised to the power 5 plus 1. 3 times 5, sorry, plus 1. Here is 3 raised to the power 5. You need to use 2 um, asterisk signs. Yes, this 3 raised to the power 5. So I'm just showing you guys with the interactive mode, there's a lot of things you can do. You can write much more complicated stuff than this. You can even, lastly, I'll show you another example. If I have list 2 equals to a list 2, 3, 4, 5, 6, and I want to use a for loop. that is going which will square print out the square of all items in the list. I can still use the interactive mode to do that. Just for x in list 2 square equals to x times 2. Now I want you to note the for statement can have a group of statements under it after the semicolon. So what you realize in the interactive mode, you have three dots. These three dots or three period signs indicate we are still within the for loop statement. This is what we call the body. This particular line is part of the body of the for statement. We are going to learn all this, but I just want to indicate to you that if in case you see three lines, know the interactive prompt believes you're still within this first statement, which still has the caret. So in this case, we are still within the for statement. This is just it's like a continuation of the for statements. I'll show you another example. So in case we write square equals to x times 2, x raised to the power 2, now we can now print it out. 1, 2, print. You must indent even when using the interactive prompt. You have to indent if you're trying to write the body of a for statement, a while statement, like I'll be showing you guys later on. So print square. Yes. Now to exit, to tell the interpreter you are no longer within the body of that statement, you need to press enter twice. So here is it. Enter, enter. Now it's going to execute this whole statement, which is a group of three lines. Three lines here. So this is the output 4, 9, 16, 25, and 36. So there is your output. This is another example just to show you if you create a list, maybe L equals to, or a tuple in this case, 1, 2, 3, and you press comma, you see the comma indicates you're still typing the list. Maybe it was very long and you want to move to the next line. You can continue typing 3, 5, 6, 7, and end it. That's all. You can print list, print L. All right. So I'm just trying to show you guys the three dots indicates you're still in the first statement with the triple carets. So you need to understand when you see three dots, know the interpreter knows you're not done with the statement above. It's a continuation of the statement above. It indicates you're actually doing what is called you're continuing the statement above. So those are a few things you should note when using the interactive prompt. And like I said, if you want to go back to the normal command line, you use exit. Exit. All right. Now you're back to the normal command line. So that's what I wanted to show you. Now, this is the interactive mode of programming. It's used to test pieces of code. You can use it to test pieces of code in case you're working on a very big project and you just want to check out a few things. You can use the interactive prompt to do that. You're going to understand what I'm saying later on when we learn a little bit of Python. You can be working on a big script or a big project and with a lot of codes, but you have forgotten a method name in Python. For example, you have forgotten the different methods provided by the list object. You can even come to the interactive prompt and type dir list. It's going to show you the methods of list. You see append, which I use. You see sort. You can even pop out, remove, reverse, index, or you can insert at a particular index. So you can use the interactive prompt to help you check a few things which you've forgotten while working on a project. Now, apart from the interactive prompts, let me clear this. Exit and CLS. So now, apart from the interactive prompt, you also have the script mode of programming. In the script mode of programming, you write a Python script within a file and you call the interpreter to interpret that file. The interpreter will actually interpret it line by line, but it's going to interpret the whole file. So the difference between the scripting mode and there are a lot of differences, but one of the main differences is the whole file is being interpreted line by line. It's not interpreted while you're writing. It's only interpreted after you're done writing. Now the scripting mode, you can use a text editor, you can use ideally Python, or a you can use a um, you can use ideally Python or you can use an IDE. Ideally Python is like an IDE, but it's quite primitive. The intelligence of ideally Python is not that good, it's quite difficult to use, but I'm going to show you the different methods. Now, a text editor, I will not advise you to use Notepad. Probably you can download Notepad++, which is you can download Notepad++, just search it on Google, Notepad++, for Windows. Here is Notepad++. I want to use it now to create a Python program. What do? I double click. I already have something. This is a C program. I don't want this. So I'm closing this. This is a Python program, but quite complicated. So I create a new file. I will save it as file. Save as. I'll save it on my desktop. I'll call it um, script 1.py. I'll save it on my desktop. Now script1.py, here is it. Okay, now I can create a simple Python program. Here is what we call a scripting mode. Now I'm creating what is known as a Python script. Some people call it a Python module or what, but this is a Python script I'm writing right now. So I can write a simple program that asks for your name, asks for your number, and then gives you a welcome message. I'll start with the URL. I'll start with creating a variable called name, and it should be equals to. In fact, I'll use the simplest method by printing out welcome, please tell us your name. Please tell us your name. I will receive the name from the user. I'll save the name in a variable and receive it input. This input is will provide the means for the user to type in its name, his or her name, and then from here I'll type print, enter your ID. Alright, so then I receive the ID. I want it to be an integer, so I'm going to convert to an integer. We are going to learn all this. This is just an example to show you an example of a script in Python. Okay, now I create a random variable called URL that should point to HTTPS .com. So I can now create a welcome message. Message equals to welcome. Welcome. I create a placeholder, your ID is, or maybe instead of ID, I can change it to age. Enter your age. Yeah, your age is something. Visit something more info. And now I use the format function, the format method of the string object, and I say name. age and URL. At the end, I print the message to the user. Print message. Now, we have created our Python script using a text editor. This is the most formal method you can use. Most people don't use this method except people who know Python very well, because if you make a mistake, you won't be able to know until you've compiled it. So let's check if there's any mistake. Looks like there's no mistake here. All right, now execute it. Once you write like this, you can execute it. I can close this. You can execute this script in several ways. One of the ways to do is to right click, open a shell. Now you need to press shift and right click. Shift. You hold down shift and press right click. You're going to see open PowerShell here. Now you can just say, you can call the Python command and your script name. I think it's script1.py. It says welcome, tell us your name, enter your age. Welcome Emmanuel, your age is 31. Visit www.techinbear.com for more. We have executed the script using the command line. We can also right click on the scripts and open with ideally Python. Ideally Python comes here with the IDE. Python is the IDE that comes by default with Python. Alright, so we are going to open it. Open with ideally, or if you don't want that, you can open ideally Python and find your script, like file, open, find it on the desktop like this. Okay, here is your file. Now to run it with ideally Python is much easier than that, because ideally Python has a run option here. Run, welcome, enter your age. All right, so here is an example. Now here is what we call the scripting mode. You can also use, to write this script, you can also use what we call an IDE like Visual Studio Code or Clips editor. If you want to install any with the Visual Studio Code IDE or the Clips, you can check out our videos on installing Clips, Visual Studio, or even Anaconda. But I'm not going to be using Anaconda now. I may use it in later examples. But for now, you can install Visual Studio Code if you want. You can look at it, you can check the video, or you can install Clips IDE. So I will use Visual Studio Code now to demonstrate this. So I pop up my Visual Studio Code and I write a simple example, um, starting by asking for your name in this case, or in Visual Studio Code, I'm going to do a different example. First, let me try to open the file I just typed in. File, new, open. I'll go to the desktop. Okay, it's already at the desktop. There's one, no, desktop. You see script1.py. Yes, open. Okay, so Visual Studio Code now, and I can run it. Visual Studio Code has a run here, so please enter. All right, so it executes from there. So here are different ways of opening a Python script. You can also write a script within Visual Studio which has very good IntelliSense. You see, as I'm writing, it's going to be suggesting stuff to me. For example, I have a list. I create a list called secret, and it has a group of passwords. It's a list. It has the password, or it's a list with names and passwords. It's a dictionary. It's a dictionary. It contains usernames and passwords. It contains okay. It contains username and passwords. So um, sorry. All right. So here is a simple program I want to create. Now, when the user logs in, it prints. You see, as you type, it shows you suggestions or code completions. So this ID is very good. It has a very good intelligence. It also gives you documentation about the programming, about the particular function you're calling. So for it's very good. If you want to program very fast, you can use Visual Studio Code or any good ID. So it says, welcome, welcome, please log in and print uname equals to. This is just an example. I'm going to teach you, we are going to learn all this. I'm just showing you an example of how you can write the scripts using Visual Studio Code. So it gives you a welcome message. It asks for your username, input this, enter your username and pass equals to input password. So um, pass equals to input. Please enter your password. All right. So pass, okay, pass is a, we are going to learn this. Pass is a preserved word because pass actually has a meaning in Python, so you can't use it as a variable name. So I'm going to say PYD equals to, all right. So those are some of the uses of an ID, integrated development environment. It shows you error before you attempt to run the script. So because you may never be able to detect that error if you've forgotten pass is a reserved word. So next we we now find if this exists for user in secret. If user equals to uname, you can create a variable called authenticated equals to false. If username equals to uname, if pyd equals to secret user, authenticated equals to true. All right. If authenticated, and you are now logged in. Else, print invalid username or password. Please try again. We now can put this within a while loop, so it runs continuously while through an infinite loop, and we put all this, we have to indent all this one way. So in this case, when we can break here, right? So let's try to run the program. They said we have an error. Keyword is okay. We had to use double. All right. Enter your username. I'm going to enter a fake username. I'm going to enter a fake username. Welcome. Please log invalid username or password. Let's try again. Welcome. Please log in. Now, please enter your username. I'm going to enter J, but with the wrong password. Please enter your username. I'm going to enter a correct one now. Drew. Drupal. Okay, was not correct. Paul and Drew. Right, you are now logged in and the program ends. So here is an example of a script that actually checks if a user enters a correct username or password. So I just want to show you guys that example. Now let's move to the next. So these are the different ways you can write a script. Now take note of a script. You saw in the interactive prompt, if you just have a statement like 2 times 3, you print it on the command line. This doesn't happen. Only statements you print out are printed out. Even if you write 4 times 20 whatever, it's not going to be printed out because you did not print out. In fact, these statements have no use because their result is wasted and it's not printed out. So you don't see it printed out. For example, if I execute a script, you don't see it being printed out. There's nothing is printed out. The outputs are not printed out. So in any statement you don't print out when you're using the scripting mode of programming, those statements are not printed out at all. Unlike the interactive prompt where if you write something like 2 times 3, the result is printed out automatically. It doesn't happen even if, and it's the same as if you print 2 times 3 or 2 times 5, let's say, printed out. If you just create a list without assigning it to a variable, it's printed out. It doesn't happen like that in the scripting mode. If you come and create a list here, and 1, 2, 3, and run your stuff, there's no sign of the list being created. You see, we already, please enter your password, we're already here, and nothing happened, so it was not printed out. So I want you to take note about that when using the scripting mode. So that's just what I want to show you guys. So let's go to the next. So you see an example of the interactive mode. Welcome to Python. Here you create a variable 30 var2 product equals to var1. You print out the product. Yes. So here you just write 20 times 40 is printed out because we did not assign this 20 times 40 to any variable. We created a list. We did not assign it to a variable. For example, list1 equals to something, and now it's printed out. Here we created a list here and assigned it to a variable, and as you can see, it was not printed out before the next interactive before the next prompt. So what you see now, we decided to print the list mlist, and we printed out the list. So this is just an example of what I've been showing you, and here is an example of a script. Like I told, print welcome to Python var1 equals 30 var2 product equals var1, print product is product. We are going to learn all this, so this, I don't really want you to focus on the code now. I'm just showing you an example on how to use the scripting mode here. So um, here is the output. So we are going to look now at, all right, okay, so It's just taking note that each time you see something like a hash, it's a comment in Python. We are going to look at that later on. So let's look at Python identifiers. So what are Python identifiers? So I'm going back here. Now, you saw me saying things like len1 equals to 10, or len or var2 equals to 20. Now, len1 and var1 are Python identifiers. I want you to know that. Or when I said list1 equals to, I created a list of variables, I created a list of stores. So all these are variable. We call them variable names. We can call them identifiers, but in this scenario, they are called variable names because we use them to store variable names. Some people simply call them variables. So sometimes you hear me talking about variable. I'm calling it len, var1, list1, they all variables because we assigned something to them. And I want you to know that in Python, a variable, a variable is you can change what is stored in a variable. For example, you can say len1 equals to 30. Later on in your program, you can still assign something to len1 different from 30. You can even give it 90, or you can even assign a string to it. Um, Something, whatever, or you may even assign a list to it later on. But what happens is that len1, the value of len1 will always be the last value you assign to it. For example, if you print len1 now, you see len1 now, you see it has 489. All these values were replaced. Initially it was 10, later we replaced 10 with 30, later we replaced 10 30 with 90, later we replaced it with a string, this was me, later on we replaced it with the list 489. So finally len1, the variable len or the identifier len1 has the value of this list 489. So that's what I want you to understand. Very important. So that's what I want you to understand. Very important. So now, identifiers have some rules to create identifiers. And what I want you to understand from identifiers, for example, when we say len1 equals to 10, Python creates, we are trying to tell Python, create some space in the RAM, because each time a program executes, its data, its code and everything is being stored in the RAM while it's being executed. That's one of the use of the RAM, the primary memory. So you're telling the computer, I want to store 10, the value 10 in RAM. Help me store it. But each time I need that variable, I'm going to use the name len1 and you're going to give me that variable. Why? Because when the computer actually stores a variable called 10 in RAM, it stores it in an address. That address is very long and we don't know that address. So this len1 stands like a tag to that address. You're telling the computer, store it in an address and put a tag len1. Each time I say len1, I'm referring to that address. Here you said store 30 in memory and put the tag var2 on it. Each time I say var2, I'm referring to that address. So check for the value in that address, which should be 30. In this case, you say create a list of items in memory and put the tag list1 on it. Each time I say list1, I'm referring to that memory location. So I want you to get that list or that value in the memory location. So variable names are like tags to memory location. The memory location themselves are very long, so programmers can't cram it. For example, you can check the memory location of a variable by using the id function. So let's say id len1, you see a very long name, look, very long. You can't cram this. That's why you actually use a tag len1. So you can be referring to this memory location. Programmers in those days were at when memory was very small, because now memory is large, they had to note memory locations. They were calling memory locations directly. But with higher level programming languages now these days where memory is large, you just need to put a tag like a variable name. So you can check the memory location of list one id list one. So you see, it's very long. So you can't cram this. That's why you find yourself using the tag name list one. We call it a variable name. And using variable names is not only for variables. We use it when we are defining functions because functions too need to be in memory. We use it when we are defining classes because classes need to be in memory. So identifiers are used for a couple of other things from um, apart from just variable names, but identifiers have rules and I'm going to be showing you now. So I'm going to exit this. I'm going to clear so we have enough space. I'm going to get back into Python. All right, so one of the rules of identifiers is that it can only contain A to Z uppercase or A to Z lowercase or and the underscore character. For example, this is a valid variable name. This is a valid variable name because it's just a mixture equals to 40. Print, I can't cram this, so I'm going to copy it. Alright, so the fact I use var1 or var2 doesn't mean you can't use anything. You can use any valid variable name you want to store your variables. So you can even use a name, John. John equals to something, maybe a list. Alright, you can even use John. So take note, you can use anything you want. Most programmers use stuff like A equals to 10, B equals to 20, but usually it's not advisable to use names because names, letters, because they are not descriptive. A programmer going through your code may not understand what A means, B means. So that's why you see us saying things like list one equals to something, or you can use something like sum or my sum. Now, in the next step now is you can start a variable name with a letter or underscore, but you can't start it with a name. For example, John equals to 30 or John 10, for example, equals to 30 is correct. Um, Psalm 40 me is also correct, equals to let's say is equals to a tuple is correct. Now, and you can even start it with an underscore. You can even end it with an underscore or put underscores can be anywhere within the variable name, anywhere. It's not, it must not be, so it can be anywhere. But the one rule is you can't start a variable name with a number. For example, first place equals to 30 is wrong. You can't start a variable name with a number. That's the exception. You can start it with an underscore. You can start it with a letter. You can start it with a lowercase. You cannot start it with a number. But numbers can be anywhere within the variable names. Equals to 5,000. Numbers can be anywhere within the variable name, but you can't start a variable name with a number. Next, a variable name cannot have special characters apart from a letter or a number or the underscore. You can't you can't have any other character. For example, if you do something like this, it's wrong because of the dollar sign. If you do something like this, equals to 50, is wrong because of the plus sign. If you do something like this, It's wrong because of the assignment operator and many other stuff. So a variable name cannot contain a any other character apart from A to Z or A to Z or 0 to 9. It must be A to Z or a mixture of, and it can be a mixture of lowercase and uppercase. For example, my first name equals to Danny is correct, or last name equals to uh, David. So what we do is a variable name can have a mixture of upper and lower case. In fact, programmers use that to be, if you have a variable name, for example, that is two words, you can use the uppercase, you can start the uppercase with a capital letter to make it so that it's clearly seen. For example, you can say first name equals to, or, or, and you can say second name equals to, um, and you can even say middle middle name of brother equals to, um, right. So let's say something like that. So you see, this is what we call camel casing. Camel casing. You see, every new word, the first word starts with the lowercase, but every subsequent new word starts with uppercase and uppercase. You have uppercase, so it's easier to read it. Some other programmers prefer to write it this way. First, since underscore is a valid can be part of a valid identifier. Most programmers write like this, and this is what is done in Python because most scripting languages we use underscore rather than camel casing. But for languages, type languages such as Java, you mostly see camel casing, while for scripting language like Python, PHP, and the rest, JavaScript, you mostly see this kind of um, variable names where words are separated with underscore. So you have first name equals to um, first name. So you can have last name equals to last name. And you can have now even middle name of brother equals to, so you can write any stuff, but I think the maximum length, you may be wondering what can be the maximum length of a variable name. I think it's 256, something like that. But you never want to have a variable name that long. That's so long and it's not good. At least your variable name should be, even this middle name of brother is quite long. You should have something a bit shorter, except it's really necessary. So next, you should know identifier cannot contain space. You cannot write first space name. It's wrong. Equals to my first name. You can't write that. There's an error because you consider this like two different identifiers, first and name. So space, you should know this. That's why you see people use either camel casing like this to separate stuffs, or people use the underscore character to separate stuff like this. So you should understand to separate stuff like this. So you should understand you can't use space within a variable name. Secondly, Python is case sensitive. So if you have a variable name equals to um, like this, it's only, you can't say print name. It's an error because the variable name is different from the variable name, which is different from the variable name. which is even different from the variable name. You understand? Or it's case sensitive. Variable names are case sensitive. Unlike maybe Visual Studio, unlike Microsoft Visual, um, Visual C plus, Visual, is it Microsoft Visual? I've forgotten that programming name. There's a program like Microsoft Visual Studio or something. No, what? All right, there's a Microsoft language, Microsoft Visual Basic. Yes, Microsoft Visual Basic. I think I've used that a long time ago. Microsoft Visual Basic. Visual Basic. I think so. The names are not case sensitive. You can think it's in all program language. No, the program language where you can create a variable called name, for example, and you can call it with name. You can say print name or even print name, even print something like name, and it actually gives you the same variable you stored here in name. Those languages are case insensitive. They don't case does not matter for them. So you should know Python is case sensitive. Variable name differs. The slightest change in the case of the letter matters. So these are different variables. These are different variables. You know, all these are different variables. Even all of them will have their value. You can print them separately. All of them exist on their own. No one clashes with the other one. No one clashes. So you see, they are all separate variables of their own. So that's just what I want to show you for identifiers. They can't have space, and Python is case sensitive. So normally by convention, the variable name should start with lowercase. I'm going to show you an example on that. If you're deciding, that's why you see me always writing using lowercase. Even when I say list one equals to something, I always use lowercase for variable names. You see, I always use lowercase for variable names. You see lowercase here. I always use lowercase. I don't say, you hardly see me writing list one equals to something, maybe a list, or you hardly see me doing this. Why? Because by convention means what programmers have been doing and which is advised for you to do. It's even like a kind of rule. Python has one rule. I've forgotten the name. Python has a rule which if you want your code to be standard, if you want to maybe work on standard Python projects, you need to follow certain rules. And one of the rules is simple variable names should start with lowercase, function names should start with lowercase, class names should start with uppercase. And like this, you can say class, car. You can do this. You can even say def. Def. I'm defining a class. Print print name. Print name self. Print name. I don't know whether I should even have self. Alright. So see def print name self. Print so now we exit our class. We can call a class. Now we can say my class equals to car. You can say my class dot print name Toyota. So that's just an example. Class name should be start with uppercase, usually by convention. So you see, meaning by convention, class name should start with an uppercase letter while all other identifiers should start with lowercase. Now, by convention too, when you start if you start a variable name with underscore, it means it's a private variable. We'll learn that when we start talking about classes. You learn what private variable means, like passwords. If you're in a database and a particular object has its password, or database object you created and you want to save the password in the script, which you should never do, you can use underscore, which means it's a private variable. And if you use double underscore, um, it means it's strongly private. You're trying to tell someone who's reading the code that this variable is, or this identifier is strongly private. It's really a private variable. You're gonna see that if you're not writing serious programs or code for big companies, you may not go through all this, but these are standards you use when writing programs, major programs. If you're working with a team of other programmers and you have people who are going to review your code, you have to follow some of these standards. There's one called, whether it's the PEP 8 standard or something like that, PEP 8 standard for Python, that allows, that forces you to do all this for your code to be considered if you're working on a serious project. Or if you want to add, Python is open source. If you want to add to the Python code, you need to do some of these things. So double underscore means strictly private. Now, if you have double underscore at the start and double underscore at the end, you're trying to say it's a language defined variable. You're going to see all that. Double underscore. And how we know that? Let me show you an example. Let's see, Matplotlib is a third-party module, but it's written to standard because it's used by most Python libraries. So let's see what Matplotlib does, how it defines its variable names. Let's first import matplot. I just want to show you that this rule is being used by a lot of programmers who design standard modules as npl matplotlib. All right, so let's see let's see the methods and whatever, all what Matplotlib has within it. Now look, you see first, you see a single underscore for a variable name. These are functions. This normally you see the capital letter. It indicates this is a class, this is a class, this is a class, this is a class. But this class is private. That's why you have it starting with an underscore. It means it cannot be called from outside. In fact, this is a class. Then this here you also see this here is a constant. If you write variable names in capital letters completely, you're trying to say they're constants. Their value don't change. All right. Here are normal functions. They start with lowercase, but you see these are private functions. They are only used within the Matplotlib module. They start with underscore, indicating they are private. You see, so you have double underscore ending, indicates this one is a language specific identifier, and you don't have double private here. You don't have double underscore here, which means no variable is strictly private. I don't think there's anyone here. I've not seen anyone. So I just want to show you this stuff is being used by, and you see the single underscore, which, okay, yeah, no, not single underscore. This starts with a underscore because this is a continuation here. So I'm just trying to show you it's used by most modules. You understand? So it's always good to follow that standard, even if you are not writing professional code, just so you get used to, because someday you may need to write professional code. We'll talk about that later when we look at classes. So let's move. Now here is an example. You see these are variable names. Now let's identify the different variables or identifiers. This one, we used it to store the text. Don't worry about the code. I just want you to take note of the identifiers. This is an identifier called text. We use it to store the string. Here is another identifier called sum. We use it to store the 30 plus 45, the result we printed. Here is another identifier we use to create a function. You see, it's lowercase my function. Within my function, we have an identifier called phi. We we call my function. Now, take note, this here is a class name. You see, we use capital letter for its identifier. That's uppercase. So within the class, we have a couple of we have identifiers, and here we use here is a function, but it's init. Init we call init normal. What init is some sort of a what we call a constructor. When we'll be learning classes, we are going to talk about it. Init is a language specific function, which means you don't actually call init anytime, but Python will call init automatically. Init used to initialize the class. It's actually what we call in programming a constructor. For example, when we created a new class here, we just passed it John Smith. Init, the init method will automatically pick up this variable we passed and initialize it to be the class, the name of this class. So you don't need to worry about that. When you learn about classes, we are going to talk about that. So here is an identifier. Right. So if you're creating a new class, you can use lowercase. You must not use uppercase, but some people use uppercase. Like, I mean, the class declaration itself is uppercase, but when you're trying to create an object of the class, we'll learn all that if you don't understand. If you're trying to create an object of the class, the object name can be lowercase. It's an identifier. Here is an identifier too. So import OS. You see, import the OS. Module is the name of a module. Usually it's a folder. When we'll be learning about modules, we'll learn about how modules are created. So this OS is an identifier, so it can be used for a module name, it can be used for object name, it can be used for class names, it's used for function names, and it can be used for normal variables. So those are some of the uses of identifiers within Python scripts. So I just wanted to show you. So now let's look at reserved words. Reserved words are words used by Python. Like you saw, we at the beginning we tried to use pass to create a variable. We said pass equals to 10. Anytime if you use any reserved words to create as a variable name, it's going to fail. And equals to 3, it fails. As equals to 10, it fails. Anyone you use global equals to 30, it fails. So as a beginner, you may not know all the reserved words, so it's good to jot them down somewhere. So you don't try to to use an identifier that's reserved. For example, you can say continue equals to true. You may be writing a program and you want to just say continue equals to true somewhere within your code, but it's going to fail because continue is a reserved word. Now, reserved words, you know about the and. And is an operator. It's a Python operator, which is normally called a logical operator. As is usually used in import. Import, you can say matplotlib. You saw me doing it as npl. Is to create an alias or an alias of an import. So we use asset for debugging. During debugging, we use the break statement to exit a loop. We use the class statement like you saw in the previous example to declare a class. You saw me creating a class here. My class, you saw me creating a class here using the class keyword. So continue is to stop or to prevent a loop execution, or to move to the next iteration of a particular loop within a loop, to move to the next iteration. We'll see all that. The def keyword is used to define a function. I think you have seen that. You saw that in this example. So all you see def, you see here is def. So the def keyword is used for that. The del keyword is used to delete an item from a list. For example, let me see if that even works. List 1 equals to to 1, 2, 5, 7, 9. Let me try to delete the second item. There, list 1, 1. Print list 1. Alright, so del is used to delete an item from a list. Um, elif, if you say if something, elif is used within an if else statement, if else, elif. So we are going to learn all that. Except is used to catch an exception when you use the try catch. We are going to learn all that when we later on. Exec is used if you want to execute a Python script. For example, I may have a script called um, x equals to 30. Here is a string. Exec is very important. It helps you to like use code like data. You can even save code in memory. You can save a piece of Python code in a string or in a database and execute it at random. It helps you to execute code based on particular conditions. For example, here's a piece of code called my code. My code equals to var1 equals to 10. Note var2 equals to 20. Sum equals to var1 times var2, and then I'll say print sum. Sum is not this product. I just want to show you guys something. All right, now take note. My code is just a simple string. In fact, if you write type my code, you see, it's just a simple string. It's just a simple string in Python. It's not a complicated string. It's a string. You can even print it out. My code. That's it. But you can execute it now. You can execute it as a Python script by calling the exec command, and you pass now my code. Right, they say there was an error. Let's see. Product is all right. So I'm going to correct the error. Here is the error. Product is there was supposed to be a comma here. All right. So now I can execute my code. You see the sum, it said sum is 200. So I executed a code within a string. So that's the use of the exec. Finally, using the try catch. Finally is what should be printed, even if an exception is called. For is used for looping. For that for x in something I've shown you from. You can say is used for in the import from Matplotlib, for example, import pyplot. It's used. We'll see all this. So import pyplot as plt. Usually that's what is done. So we're going to see all that. From global is used in functions when you want a function to access a global variable. You declare that function within you declare that variable within the function as global. We know about if else. We know about import in. You can use it for lists. For example, you can have a list called created a list. All right. You can check if 5 is in the list. You can say 5 in list 1, and it's going to be true. So that's the use of in. Is to check if we'll check that we'll look at that later when we look at different type of when we look at the different type of operators in Python. We are going to look at the is. Is what we call the identity operator. It actually checks if two variables point to the same object in memory. Lambda is to create lambda functions. Not is also a binary, which is also an operator, usually called the logical operator. or it's a logical, it's a, I think, or it's a logical operator too. Then we have pass. Pass is a way of it's like if you have a function and you want the body to be empty, later on you want to put some stuff inside, but at the meantime you just want to declare the function so you don't forget. Within the function body, you can write pass. Pass means there's nothing to see here. The interpreter can keep going. So the interpreter passes it. But if you put nothing in the body of a function, you're going to have an error. So we use the pass. We are going to see that you use the pass statement to tell, even in an if statement, wherever every statement that has a body, can put pass in that body to tell the interpreter you can keep going. It's like pass, telling the interpreter to pass. You should not worry about the body. So we are going to see that we have looked at print. Raise is used for exception. If you want to raise an exception within your code so that it can be cached by the code that called it or executed it, you can use cache. Try, we can use try for yes, try. We can use try. At the right hand side, you can use try. You can use, know about the while loop. Wait is when you open a file, and yield, wait, you use wait to open a resource that should be automatically closed by the interpreter or by Python, so that if you forget to close it, it's going to be closed for you. It's very important because if you're working on a server side, it has a limit to the number of, for example, files that can be opened or the number of databases that can be opened. And if your website has multiple requests, you may end up with multiple open files if you forget to close them, and your requests may begin to fail with a 500 error or internal server error. So what you want to do most times is to use with in your script to open resources, so that Python will help you to close them immediately the resource is you've done using the resource. So yield is used to create generators in Python. You can create a generator to constantly generate a particular type of number or a sequence of numbers. So generators, we use the yield statement within the generator class to put out those values. So normally we are going to look at all that later on. For now, just know these are some of the main keywords. Can't use them to create variable names. That's one thing you should note. You can't use them to create variable names. You can't use them to create variable names. You understand? So lines and indentation. So as you can see, lines, unlike other programming languages, in Python you must follow strict rules when writing code. You should take note. I'm going to show this example with a script. Let's look at the script in Python, or let's use ideally Python for that script. Now, let's say you have a function. Um, let's say the user enters a score. Score equals to int input. Enter your score. All right. Input. Enter your score. Now, if score is greater than or equals to, we are going to learn all this. I'm just showing you an example of how what is meant by indentation in Python. If score is greater than or equals to 80, um, this score is greater than or equals to print. Very good. You deserved it. Yes, print very good. You deserved it. Um, add a bonus. Bonus equals to 5, or equals to 10% of score. 10 divided by 100. No, 10. Let me see. It's 10 all over 80. times 100 and final score final score equals to score plus bonus. Print your final score is final score. So here is just a simple program that actually takes the score from a user, and then let's exit here so that if this doesn't happen, you're going to say print you don't deserve extra marks. All right, let's see how this program runs. Now let's see how this program runs. Enter score. I may want it to look nice, so I'm going to say enter your score. All right, enter your score 40. You don't deserve extra marks. And run again. 85. You deserve it. Your final score is 97.5. All right, it's showing this because I used exit normally. Let me say exit 1 and see. Run 5. All right, so it's because I use exit, so that's what happens. Normally you can use an else statement, but I do not want to use an else statement. So now notice something. You see, within this, the indentation is the same, 4 spaces. 1, 1, 2, 3, 4. Within this if statement, it has a body. We are going to it has a body. The body of the if statement must have equal indentation. If any of these statements is indented one less, the code is going to show an error. It's not going to execute. You see, there was an error. The root unmatched on the complaint about the indentation. Let's see. On indent does not match any outer indentation level. So there must be an outer indentation level to indicate you have ended the particular. For example, the if statement, it ends at this point. Here it actually ends here. From here ends here because this is indented at the same indentation with this if. If you check this here, line 3 and line 9, you see they have the same indentation. So the if statement is going to end at this point at line 8. It knows line 9 is not part of it, so it's going to end there. Now, why? The reason is Python forces you to indent to indicate the body of a statement. In other programming language, you may have something like this. If you're from C or other languages, you see they use curly braces like this. Yes, so you don't need in those languages you don't need indentation. You can even write like this. Doesn't matter. These curly braces indicate all these statements are the within the if statement, so you don't need. But because Python does not use curly braces, Python uses only this semicolon, this colon. So it needs to know the body by, and it uses indentation, how indented the eye knows everything indented equally is within the body of this. We are going to learn more of this as we will be coding, but Python knows every stuff with equal indentation is print. So let's say for example we did not this is not part. Let's say at this point we ended. What is going to happen is the code is going to execute, but only these 3 statements are going to be executed if the score is greater than 80, because at this point Python will know this is not part of the if statement because it has equal indentation as the if statement. So let's see, you're going to discover that the program is going to crash. At the, take note, it's going to crash when we write five, for example. It crashes because I'm going to show you why it crashes. We'll learn all that later. It crashes because at this point the program ends and it tries to print final score, but since this was not executed because the user had a score less than 80, this final score was not defined. Do you understand? So it was not used. Let's say we did not even write final score, we just have something like this. If you run it, it's going to run, it's going to run, but you just say you entered your score 7, your final score is something, it's empty. So I'm just trying to show you guys that print indentation is used to delimit the body of a particular statement that can have a body. So the body, it must be equally indented. Once the indentation is equal to the indentation of the statement itself, it knows that's the end of its body. So at this, the if statement actually ends on line 8 because the indentation of line 9 has the same indentation of the if statement. So let's say, for example, we want this loop to run continuously and we want to put it in a while loop. We are going to learn loops later. I'm just trying to show you how indentation works. And now we say 1, 2. Okay, no problem. It's okay. It's okay. You have to put this. Now, indentation can be any number. For example, now you realize that the while loop, after this, let's have a by print goodbye, goodbye. All right, so in this case, I'm going to break from the while loop instead of exiting. All right, now note the while loop starts here and ends here. It ends here because this print statement here is the same as the indentation of the while loop. The if statement starts, the if statement body starts here and ends here because this print statement has the same indentation as the if statement. So let's see now how the program runs. You may not really understand, but for now, I'm just trying to show you how indentation works. Okay, we're supposed to end this with a colon. Let's enter score 50. You don't have extra marks. Okay. We have a mistake. There was an infinite loop because when you say you don't have extra mark, it went right back to the top. So normally I have to break at the end. Um, Let me just break at the end instead of breaking here. I'm going to break here. So it's never going to run. So let's say we do this. So just notice the while loop, the body of the while loop now is going to end. The body of the if loop, this is it. They have the same indentation. The body of the while loop, here is it, equal indentation. So you can put a statement, if statement can exist within a while statement, but just note their bodies have the same indentations. So here is the indentation of the if statement. It ends at this point because, as you can see, this print statement has the same indentation as the if statement, while the while loop ends at this point because this print statement has the same indentation as the while statement. If you don't understand, you don't need to worry. You're going to still understand as we keep writing code. So it's going to run now. 80. You you don't deserve it. You deserve extra marks. You don't deserve extra mark. Whatever. So yeah, instead of using if, I can use something like an else. So you should not do this again. You should not write you don't deserve extra mark again. All right, so now it's going to run correctly. We are going to learn all this. I don't want you to really focus on the code. That's why I'm not like, okay. So it's good now. So I just want to show you that. Yes, so that's what we call indentation. If you look to the right of the screen here, you're going to see this if true. Here is the body, this else, here is his body. Now you're going to see again this while loop. Here is his body. Next, this while statement within this while loop. This other while statement has its own content or its own body or its own suite. Those are there. So I'm just trying to show you guys that. So we should take note of that. So um finally, we're going to end with multi-line statements. For this part, there's going to be part two of this introduction to Python tutorials. This part one. So we are going to end with multi-line statements. Now, let's assume you're writing. Let's assume you're writing a script. You want to write a name. Let's say a message equals to, and once you're writing, something happens and you have to continue writing this message. What do you do? In Python, you use what we call a backslash here and continue writing from down. Then continue by writing another backslash and continue writing from down. So you can write and then end and you're good to go. You print message now. It prints the message. But without that backslash, you have an error. For example, look, if I try to write equals to, if I try to write some message and I press enter, it gives me an error because it thinks I'm trying to end. The backslash tells Python, please, I want to continue on the next line. Let me do it. And Python says, okay, go on. You can continue in the next line. For example, I may want to add some strings together. I may say str equals to plus another string, and I want to like add some other string plus, but I can't do it here. I can now use backslash again, tell Python I'm continuing from down, and I continue adding strings to this particular string plus. So, so if you want to add statements, if you want to write statements on multiple lines, you need to use the, the backslash. Backslash tells the interpreter, I want to move to the next line. Please allow me move to the next line. For example, if you're writing an array, let's say you want to write a matrix, a 3 by 3 matrix. I write matrix in the form of a list. Most people want to do that. You can want to write a 3 by 3 matrix like this, 3 5 3 5 comma 6, and you want to go to the next line to continue writing the matrix. What to do is you can write comma and you use the backslash, continue writing the matrix here. You continue writing the matrix 5 3 6 6 10, print matrix. Alright, so you see, instead of writing it straight, you decided to write it like this so that it will be more visible, but you have to use the backslash. If you attempted to do this without the backslash and you just went to enter, what happens? It still shows you triple dots. Why? Because a statement that ends with a statement ending with a comma automatically tells, if you end a statement with a comma and move to the next line, it automatically still tells the interpreter you are not done typing. So those that's just something you need to also note. If you want to move to the next line, you can easily use a comma. So that's just something you should note. So you can still do it like this. It's not bad. 5, comma 2, comma 4. And even use a comma and then 3, comma 6, comma 10. So all right. So you can do it in this way. Yes, but if you're not using a comma, it's always good to use a backslash. I don't know that this is even possible. Yes, you see, you're not using a comma now. You need to use a backslash, but not you're supposed to continue with the comma down here. So this may you may not need this anytime, but I just want to show you this actually exists. If you don't want to use a comma, you need to use a backslash here. Backslash just tells the interpreter you're still continuing, you're not really done, and it should give you a chance to continue down. Now you can end it. Now you can't try this normally here because there's no comma. If you type like this, all right, it still works. It still works. Oh, that's nice. It still works. I think it still works. But I think you need to continue with the comma. So I think when you're within a list, wherever you end, it knows you're trying to continue from the next line. So that's great. But in most cases, when you want to move to the next line while typing, in normal cases, in normal cases, what you do is you have to use a backslash. For example, if you're adding two string, my name plus, and you want to move to the next line, you have to use a backslash. You cannot write plus and just press enter to move. You need to use my name plus. You can move to the back line, backslash like this. Red is, you can want to continue plus, you see David. You can now select it and press enter. My name is David. So those are just examples of how you can code using multiple lines. So like I showed you here, as you can see from this, this is what we were discussing before about how other languages use braces to separate the body of statements, but Python doesn't use it. Python uses indentation. Indentation is the distance from the left margin. So indentation, Python uses indentation to mark the body of a statement. So these are examples of multiple line statements. You need to use the backslash character to do it. But if you're within a list, the comma just works. And not only if you're within a list, if you're within a list or you're within braces, any form of braces you're within. For example, if you're writing a dictionary and you write my dict, my dict equals to, we'll learn Python dictionary later. Name is Jude, and you write comma. You see it continues. Why? Because of this. Because of this. So you end it. Age is age is 20, and now you end the dictionary. So print my dict. All right, name Jude, age 20. So I'm trying to show you if you're within any type of braces, if you're within this type, a square bracket, a curvy bracket, or you're within curly brackets. Normally, if you move to the next line, Python actually knows you're still within those curly braces until it sees the end of the braces or of the bracket or whatever, until it sees the end of the bracket like this before it knows you're done. That's why the starting bracket indicates you're starting something. So once it does not see the end, it knows you're still on that stuff you were doing. So is the bracket braces or square brackets that indicates you are actually still within the statement. So I just want you to understand the concepts. All right. So I think we are going to end here. Here is just an example showing some of those things. I think we are going to end here for now, and we'll move to quotation in Python in the next video. All right, so see you in the next video where we're going to be moving from where we're going to be continuing with quotations in Python. All right, see you later.